Hi, so I'm Scott, and I'm going to be presenting on Terraform best practices. So when we think of Terraform, the first example that most people do is going to be deploying an EC2 instance. There's not really a hello world example, but if there was one, this would be it for sure. It's very rewarding to see EC2 instance be created, and you get to learn how the Terraform apply works, how the Terraform destroy works. And I think this makes a lot of sense. This is part of the value of Terraform, where you can have the declarative infrastructure as code, and it's provisioned exactly as you want. However, in the real world, we're going to have more resources than just EC2 instances. We're going to want to deploy things like auto-scaling groups and load balancers and VPCs and IAM policies. And we also have more providers that we're dealing with. Any of our cloud vendors, for example, are candidates if we're doing multi-region or multi-cloud. And then we also have dynamic infrastructure. So infrastructure that maybe doesn't fit in with the traditional way of thinking about Terraform. So how do you deploy a Helm chart? What about Ansible integration? What about scripts that you need to execute? And how do you reconcile this with what Terraform is as a technology? And then this is just a diagram showing the multi-cloud capability of Terraform. I think this is one of the greatest strengths of Terraform, the fact that you can use multiple providers for the different cloud vendors, and you can just as easily deploy something onto AWS as Azure or GCP, like we do at Snowflake. We have multi-cloud capabilities with Terraform, but this does pose additional challenges. So these complications that naturally arise bring certain questions. For example, how do you structure your code? How do you safely apply Terraform changes? And what about architecture principles? Do we have any architecture principles? And for this talk, I wanted to first introduce myself. So I am and the author of Terraform in Action. I've been working with Terraform for many years now. I'm currently a senior software engineer at Snowflake, where I serve in the capacity of the admin of Terraform Enterprise, as well as just general Terraform expert. And then in the past, I was the HashiCorp ambassadors, core contributor. I also spoke at HashiTalks and HashiConfs. So I've been pretty involved in the community. I've created multiple providers, and I'm just happy to share with my experiences working with Terraform. And I can't exactly say that these are all what is best practice, but this is from my experience what I would recommend. So the agenda today, I think we'll start by talking about modules. And how they're useful and for Terraform for structuring, organizing code, and different pitfalls that might arise from that. And then the principle of just keeping things simple. I think there's a tendency to overcomplicate what Terraform can do. And so really just focusing on the key attributes of what makes Terraform valuable, and then trying to reduce complexity. Then input variables, I think that there's a lot of arguments on input variables that should be set. So that's just kind of a discussion about that. And then safely applying Terraform changes, as well as finishing up about general architecture principles. I mean, these are kind of high-level discussions, so I wanted to save those for at the end. So modules. Modules are pretty great. If you haven't been using modules, you should probably be using modules. There are, what are modules? Well, they are lightweight abstractions of Terraform configuration. I kind of think of them as self-contained black boxes, where you can worry about the inputs and outputs of the module, but not necessarily the details of what happens inside there. It also reduces cognitive load, because if you are working on a particular module, you only have to consider the resources that are declared within that module. And then you can build up your architecture from using these modules as a sort of building block. And then what I have in this diagram is a Lego picture where, I mean, this is how I think about Terraform, where the resources, the modules, the data sources, they're all different kind of blocks that you connect together. And the modules, where they come in handy is that you can connect very different pieces together, but just the only thing you have to worry about is the way that data goes in between the modules. And that's the principal complexity of modules, I would say. But the fact that they serve as an abstraction more than offsets that. Okay, so the first way of, I would say, maybe structuring a module, or maybe the first people that would write a module would write a flat module. I don't think this has a particular nomenclature, but this is what I think of it. It's where you have a folder or a directory that has many files, all with .tf suffix. So main.tf, im.tf, maybe if you had an S3 resource, you'd put that in s3.tf, and so on and so forth. I think this is rather simple way of organizing your resources. It's very quick. You don't have to even really worry too much about modules. In fact, many people don't even think that they're using a module when they're organizing their code like this. This is actually untrue, because it's technically a root module. So you're always using modules, whether you know it or not. But I think that this is maybe only useful for some use cases, as it does encourage a high degree of coupling between your resources. You have to worry about more resources together, almost like global variables in a way. Like, where do you find certain local values? And then there's just more things to worry about. And it can be hard to navigate the project structure if you don't know how it's organized. Just to give you an example of what a flat module structure might look like, it would be something like this, where I have all these .tf files. And I guess the problem for me is, if I was not familiar with this project, where would I find a certain resource? I mean, would it be in, like, if I was looking for an IAM role, would that be in IAM.tf, or would that be next to in the EC2.tf? I don't really know. So I think that this is maybe, when you get to a certain level of complexity for your project, maybe flat modules are not the way to go. I think there is some use cases where the flat modules makes a lot of sense, particularly if there's not a lot of coupling between resources. Each resource more or less is its own thing, and you can use the file names as a form of organization in and of itself. For example, we use Terraform to manage Terraform Enterprise, or you could use it for managing GitHub or other kind of SaaS providers. And we have a module for each organization, and then the files in that module can provision workspaces. And so these workspaces are very independent of each other, and it wouldn't make sense to put these into modules or even in the same file, because then the file would be too long. So being able to have them as files that are uniquely named like this makes it very easy to find what you're looking for. And I think this is a good use case of the flat module structure. There's also nested modules, which I guess is maybe the true definition of using the modules that most people think of when they use modules, where you have this root module at the top, and then you have these nested modules underneath, modules A, B, C, and they may have their own submodules. And then you pass the variables to the root module, and then that gets percolated down to the other submodules. I think the problem with, or the difficulty with this is data flow. You do have to make sure, like, if you have data in module A, or maybe a submodule ABA, and you're trying to go over to the other submodule CBA, you have to send the data all the way to the root and then all the way down to that other module, and that can be difficult, but that's partly has to do with the way that you architect your project. You want to make sure that resources that require outputs from other resources are closer together, so that you don't necessarily have to do this kind of complex data flow as much. But as much as I don't like this, I do think it's important. It does provide the principle of least privilege, like you can share least information between modules. And I do think this is a good way of organizing your code. Speaking of that, there's actually a standard module structure that HashiCorp created. It's they name their files in a certain way for the module. You have a main.tf, variables.tf, outputs.tf, so on and so forth. It's required if you want to publish any module in the module registry. Of course, you can name files with any .tf that you desire, but this is what's considered convention. I just as a side note, I really wish that they hadn't stuck with variables.tf. I always thought that inputs.tf made a lot more sense, especially because alphabetically it would appear before main.tf. But anyways, the variables.tf is what is convention. And if you want to know more about that, there's the link to that, to the documentation for this. Another thing is, it's very important to keep modules focused. You want to make sure that you don't have just one module that just does everything. It's very tempting that I think, because Terraform can do so much, that you just want to do your entire deployment with Terraform. And I guess the problem with that is that you have a lot of risk associated with having your entire deployment being done in one go with Terraform. And it also can take a long time because you have a lot of resources. And also you lose cohesion, because what is that module doing now? It's not really a module anymore. So I think if you can split this project into maybe reusable functions, or reusable modules, I should say, that you can use in other kinds of Terraform projects, then that saves you time later on. Not everything can be reused, but you should try whenever possible. So I thought this was kind of an interesting example of maybe how not to do a module. So this is something I found from the registry, and just take a look at the red circle there. 77 input variables, and then in the blue circle, 5 resources. So if I am somebody that's going to be using this module, I think it'd be easier for me to just reverse engineer the module and just look at the resources that you're using, and then look at the documentation for those resources, than it would be to use this module. So modules should be lightweight abstractions. Keyword lightweight, because I don't want to be setting all of these tuning parameters. I think that kind of defeats the purpose of having the module. It should be saving us cognitive effort, not increasing it. And so this is maybe a bad way to organize modules. I think that there are some really good examples in the registry. Like, for example, like I really enjoy like the VPC module from the AWS provider. And another thing to think about when organizing modules is, how do you group resources together? So ideally, you should organize resources by the dependency, least to greatest. So that it's readable. And then again, this is cohesive. Like, modules should feel cohesive. And this is kind of a hard thing to exactly say what that is. But I like to use this example of marbles, right? So let's say you had a collection of different colored marbles, and some of them are different sizes and they have different colors. Some of them have swirly patterns on them. And you want to organize these, but you only have so many bags that you can put them in. So you don't want to have a single bag for every marble. That wouldn't serve any use at that point. So you could do is you could say like, okay, I'll have all the green marbles together, I'll have all the blue marbles together, I'll have all the red marbles together, and then you within that subcategory, you might have them organized smaller to larger, and that way, even if you don't know exactly where something is, you can find it, kind of like a dictionary. And it doesn't matter if some of these marbles don't exactly fit in to the group. So it's about what makes sense to you. So just as an example of these dependency, like least to greatest, what exactly does that mean? Well, look, I like to put it, the resources that have fewer dependencies at the top, because when I'm reading it, reading the code, I read it top to bottom. So for example, this random string resource, I'll declare that first. And then I use that in the next part so that I can already see that it was declared, and then I'm using it. And then I use it, that local value over here. So it just makes sense when you're reading it. It's not procedural code, but we can still organize it in a way that helps people that are trying to read and understand what your code does. People shouldn't have to hunt for where you declare your local values. I really think that the local values should be declared right before where they're being used, rather than I've seen some people that they'll create a locals.tf file and they'll throw all their local variables in there. And I just don't know that has so much benefit. But I think there are some use cases where that could make sense, I suppose. Okay, so modules, they have sources. You have remote modules and you have local modules. So remote modules are anything that's not on your local computer. So that could be GitHub repo, S3 bucket, Terraform registry, whatever. You can just HTTP URL, this could be the Terraform registry. So I think the advantage of the remote modules is it does encourage code reuse. Because if you have a module and you have a similar use case where you need to do something very similar, this is where that architecture, building blocks with Legos kind of comes in, that you should be able to take these modules and put it in a new application for some new architecture that relies on that. It's also easier to do version them. Actually, you have to version them for the Terraform registry using tags. And then it makes it a little bit easier to test, because if you have the code in isolation, it's much easier to just test that it's working as you intended, rather than testing an entire massive Terraform deployment that has hundreds of resources in it. It's very hard to test that, because the only thing you can do is just stand up the infrastructure and then just hope that it works the way that you intended. And there could be a lot of problems with that that you didn't expect. Another problem, but the remote modules do require a bit of setup work. And I would say that would be the main disadvantage of it, because you have to put it in the registry, you have to put it in the S3 bucket, you have to know that you want to have it reusable. I think if you know that you're not going to reuse the code, you really shouldn't make it a remote module. Like local modules still serve a good purpose because they're quick and easy. They don't have any versioning, but you're always using the latest version, I suppose. They are a little bit less reusable, but sometimes that's okay, because sometimes you don't want to be reusing code anyways. And you can use environments for Terraform and such to use local modules effectively. So I use both. In terms of versioning, the local module doesn't support versioning, so you can't do that. You could, I suppose, create a folder with an underscore v2, but I wouldn't recommend that, because now you're copy pasting your code around. Then the Git modules, they have references. I think that's really valuable, but I think the registry is probably the best, only because it supports this meta argument for version constraints, which is very useful. Allows you to say, like, I want to match anything, any minor version change, but not a major version change or something like that. Other module considerations, you should definitely version constrain the provider within modules because it's very possible you can test the module for a specific version of the provider, but you don't know if it's going to work on the next major version of that provider. So this is just some way of letting the people that are using your module know if there's some kind of incompatibility. And you should give a range of allowable values so that it's not going to give them an error if they don't match the exact version that you tested it with, but at least for the minor versions, certainly. Another thing is I like to keep the root modules simple. So kind of going back to that nested module design, which I'm pretty fond of. I think the root module should really just be used to declare the other modules that really have the business logic of your application or deployment or whatever. The root module shouldn't have too much going on in it unless you were doing a flat module, in which case then you can eschew that rule. Then another consideration is please don't use symlinks to other files. I've seen people do this, and I don't really think there's any benefit for it. I think that for Terraform, you should really just declare the code in the files as it is, and that may require some copy paste, but at least you're not editing files that you wouldn't necessarily expect to be edited. Okay, so part two of the talk is now keeping things simple. So we talked about modules, how to organize modules, why they're great. Now I kind of want to change topics and talk about why you should keep things simple. So I think the tendency is to use Terraform to do more than it was intended to do. I've seen this before with Jenkins and with other popular technologies. You just use it as a golden hammer, right? So you want to have Terraform deploy not only your EC2 instances and your S3, but you find that there's a local exec provisioner, and you can use that to deploy some scripts as well, or make some database changes. And I would just advise caution against that. I think that Terraform is not suited for every task, and you really shouldn't try to force it into to do things that it wasn't meant to. There are other tools that are better at some tasks than Terraform, if that's hard to believe. So in the point of avoiding clever code and keeping things simple, I really think you should avoid overuse of for expressions. So this masterpiece is actually something that I wrote for a project, and this was because I didn't have any other way of doing it at the time. Now there's a resource or attribute on the resource that allows you to not have to do this, but this is just really confusing. Even me going back trying to understand how this works, I don't think I could explain it to you. And I was the one that wrote it. And this is, I think for expressions offer a lot of value. They allow you to do a lot with Terraform that you ordinarily couldn't do. But we should also not treat Terraform like the programming language and because it's really not. And if you need to do some complicated queries or something like that, maybe you should do that before and just input that as an input variable. Maybe you should think about making a pull request to your provider and creating a new data source. I think there's or maybe you should have a different stage in your CI/CD pipeline that goes and fetches this information. I think that there's different ways to go about doing this that don't involve writing very complicated expressions. Another thing is you should avoid the use of this Terraform remote state data source. People use it for being able to get the outputs or the state file from one Terraform deployment and then inject it into something else. For example, like in this case, they're using some state file that was used to deploy VPC, and then they're getting the subnet ID from the outputs and configuring the AWS instance here. It is convenient, I think, but it does possibly expose sensitive information. Your state file is considered sensitive information. So when you're passing this entire state file around just to be able to get the outputs, it's maybe not the best idea. Terraform Cloud does have a new resource that allows you to get the Terraform outputs if you need that. I think maybe it's better to just publish the data to some external location, so that maybe an S3 bucket, maybe some kind of accessible data store that you can save between different runs, maybe just using the data sources for the different providers. Like you could have just used the subnet data source instead of getting the output in this example. So I don't think it's the worst thing to do, but I still can't find myself to recommend it if you can find a different way. Local exec provisioners. So this is where that golden hammer kind of comes into play. So local exec provisioners allow you to execute arbitrary code during the apply as well as the destroy. So you can do apply runtime and then destroy time functions. So in this example right here, I have a cowsay resource. So cowsay is like a script executable that allows you to print a cow and then you can give it something to say. So in this case, I'm having it say hello world. And then there's also the destroy time one, which is not shown here. But if you were to run Terraform destroy, then it would say goodbye, cruel world. And I think that the provisioners, there's better alternatives in most situations. A lot of this was more common when there was fewer resources supported by providers and you really needed to do something, but there wasn't a resource for what you needed, or there wasn't a provider for what you needed. In a lot of cases now, there's just no need to do local exec provisioners. There tends to be providers and resources for these situations. So I would just advise caution against this. Even worse is the external provider. So if you don't know what this one does, this one's even more dangerous than the local exec provisioner. The reason why is because it's a data source. So it runs during the plan. At least the local exec provisioners, you have to attach it to a resource. You can't attach it to a data source, which means at the very least, it can only run during the apply or destroy. In this case, though, with the data source, it could run during the plan, which means that you could use it to steal sensitive information during the plan. Even if you're using Sentinel, for example, like this would run before even Sentinel is applied. So you could get your AWS access credentials that were used to do the run. You could run any kind of arbitrary software on the machine that is executing Terraform, and that could be at a privileged server or in a privileged location. And this is actually, because of this provider, is actually why you should not trigger automated plans from forks and GitHub. You should only do that from branches just because of this data source that exists. But actually, there's other kinds of providers too that could do very similar, like the HTTP provider, really any kind of unverified Terraform provider. And this is another reason why you should lock the provider versions. There's a requirements providers file, and I typically put this in the versions.tf file. You have a dependency lock file, which was introduced recently. So I think that you should really just exercise caution in the providers that you choose, and just be careful with your choice of providers. Okay, so input variables. So input variables, I think, are not always utilized to their fullest potential. So there's actually quite a few meta arguments on variables. So you have default, which makes it so that the variable is can be optional or not optional. And a lot of people know about this one. And then you have types, but there's actually many different kinds of types these days. And then description, validation, sensitive, and nullable. So I just kind of wanted to go through the ones that I thought were the most important, and then how I would recommend to use these, because it's a form of communication. It's also a form of validation. So default, I do think that this is a useful one for setting optional values, but please don't use this to set required variables, especially not like sensitive required variables. In this case here, like setting a vault token is probably a bad idea. The reason why is because you can easily check this into source control and then have your token in source control. It's much better to use a terraform.tfrs file, and then you can use the git ignore to just not check in that TFRs file if that's a sensitive value. Or you could have like a sensitive.tfrs file, because you can actually concat the different TFRs files together, or you can use multiple TFRs files as part of your deployment. So you can have like a special place for your sensitive Terraform variables, but please don't set them as default. And then at default, I would also recommend, like, if something is optional, you can set the default to null. I think that's a good way of, instead of setting it to like an empty string or something. I think setting it to null, it makes a lot of sense. Type constraints. So there's the primitive types, which I think everyone knows about: string, number, Boolean. But there's also a lot of complex types, and some of these were introduced in Terraform 12, but maybe not everyone knows when you would want to use all of these. I think that the objects and the sets in particular are pretty valuable. So the objects allow you to declare exactly the type of the inputs. So like, and this is an example of why you would want to use types, right? So if you are contributing to some code, and you see this variable Docker ports, and you wonder to yourself, like, what is this? And maybe someone sets the type as a map, and or just type any, it was the default, and that doesn't really tell you any useful information. Whereas the example on the right, you can clearly see that it's a list of objects in different cases. Actually, in this case, it might be better to have like a set of objects, but list of objects is fine as well. And the sets are and maps are useful for doing the for each expression. So sets are really not too much different than lists, but you do need to use them for each. And then I haven't really found too much use for the tuples, but yeah, I definitely think that the types serve as a form of communication to people, and documentation to the people that are reading your code, as well like how it should be used, as well as enforcing that if something unexpected gets passed in, that'll be a runtime error, and that should be a runtime error. So then the second one would be the description. So you definitely want to be kind to yourself. You've got to think about the person in the future reading this code. Maybe not just you, but maybe other people as well. You want to put a helpful description. In the first example, just calling it vault token, that doesn't tell you any additional information than you already didn't know. So in that case, I may not even put a description, because what is the point of having a not helpful description? Whereas the second example, it just provides a little bit more detail about what that variable is and where it's being used, maybe a link to some documentation. Sensitive variables. Sensitive variables, they can, you should definitely use them. They prevent secrets from being outputted into during the plan. For example, like if you set this password as true, then it wouldn't appear in the local in the output. So even using this this null resource with the local exec provisioner to print it out. If this wasn't sensitive, then it would appear. But in this case, because it's sensitive, it says output suppressed. And this actually stops a lot of potential leakages of sensitive variables. And I really think that you should use this whenever possible or whenever it makes sense to do so. And they have some functions as well for setting variables as sensitive or non-sensitive if they weren't already. Okay, so safely applying Terraform changes. Okay, so I think that the biggest, disappointment that many people have is when they have a successful Terraform plan, but then the apply fails. And the question is like, well, shouldn't the plan be definitive? If the plan succeeded, it says it's going to create these resources. Shouldn't that be exactly what my apply is? And I think in most cases it is, but there are situations where that would not be true. So I think the first example is, are your credentials valid? Are you using the same credentials that you used during the plan? Your credentials are not expired, for example. Resource collisions is another one. So when Terraform does the plan, it actually doesn't check to make sure that those resources already exist or that there's going to be some kind of collision with the resources that exist. So you have to know ahead of time whether you're going to have these resource collisions. I mean, you can have Terraform tell you this, but that would maybe you should put some foresight into like the way that you name resources to prevent something like this from happening. Another thing is there could be an unspecified dependency. So I try to use implicit dependencies wherever I know that a resource depends on another resource. I will try to put an implicit dependency just because the risk of having like a unspecified dependency, it could lead to a race condition where 99% of the time the run succeeds, but then the 1% of the time where some API operation took longer than normal, and then now suddenly you get stuck in a fail condition. So you don't want to be surprised here. Even explicit dependencies are okay, although I haven't felt the need to use too many explicit dependencies recently. I think implicit dependencies is the way to go. API limits. So this is just something from the cloud vendor side of things. And then in some cases also the provider bugs, especially if you're using less commonly used providers or niche providers. There could be bugs in the provider, and that could also get you stuck in a bad Terraform state as well. So just something to be aware of. And this is the general checklist of things that I go through when trying to figure out problems. But also Terraform will tell you. So I think the burden is on the user, and maybe this isn't what a lot of people want to hear, but I can't tell you exactly how to do a successful Terraform apply because it's up to the person making the changes to understand how it will impact the system. And you have to know, is there any single point of failure that could be the problem? So definitely, your architecture, the dependencies, and what the changes you're making. So the burden is really on you. One thing that you can do, however, is that you can make smaller deployments. So this is something that I've been favoring recently. So again, going back to that monolith Terraform deployment that just does everything, I find that it's hard to make changes to the Terraform configuration. The plan can be very slow. It can take 10 minutes sometimes just to generate the plan. And then it's making a lot of API calls to do the refresh operation. And it's also very risky because you're touching so much of your vital infrastructure. And so if anything goes wrong, it can be very difficult to get into a good state. I think the smaller deployments, like having a workspace that just does something very specific and then you can deploy multiple of these workspaces. Like, for example, you could set that one workspace to deploy your network, and then one workspace to deploy your database layer, and another to deploy your Kubernetes cluster. And maybe some people would disagree with me on this one, because it is very convenient to have just a Terraform apply just to apply everything. But from what I've seen, and it's more having to do with the longer term maintenance of the project, that you actually do want to have more Terraform workspaces, and that may require some connection between how you do the deployments, but I think it's still worth it. So that kind of leads me into the last topic, which is Terraform architecture principles. So I think about Terraform as a great tool for deploying static infrastructure as opposed to dynamic infrastructure. So by static infrastructure, I mean things that infrequently change. You're not doing the Terraform deployment all the time, and they tend to be the foundation of whatever it is that you're deploying. So think about like setting up your network. Think about deploying your cluster. This is not something you're doing all the time, and it can be okay if the Terraform plan takes a long time. It can be okay if your Terraform apply takes 30 minutes, because you're not doing this all the time. You maybe only do it once a week or once a month, and that's fine. You're not touching this all the time, and that's just how it should be. But you also have other kinds of infrastructure, things like that may be changing all the time. Classic example would be like Helm charts or application deployments, and these things they change all the time, and they're deployed on top of the static infrastructure. So, for example, I might do a Terraform apply to apply my infrastructure, and then maybe I use some other kind of tool to manage this dynamic infrastructure. You can also use Terraform. I mean, there's examples of people using the Helm provider for Terraform, the Kubernetes provider for Terraform to deploy their applications. Again, they do this two-stage deployment. Right. So they deploy their infrastructure first, and then they deploy whatever their dynamic application infrastructure. They deploy that on top. And that might be with Terraform. Like, you might have another Terraform workspace that does that. You might have another tool that does that. Ansible, for example, you might have, I don't know, Chef or Puppet. So the same idea goes for containers as well. So you use Terraform to provision the infrastructure, and then maybe some other tool that's better suited, or whichever we prefer. I'm not going to tell you how to do your deployments, but I can just give you different recommendations depending on how you prefer to do things. So Terraform with Ansible, I think this actually makes a lot of sense, especially if you're deploying things like EC2 instances. So in this case, like, I would deploy my EC2 instance using Terraform, and then you've got your state file, which maybe has some of your dynamic inventory, and then you use your Ansible playbooks to do the application configuring. So this is something that's going to be rolling out all the time, whereas the Terraform provisioning, maybe you don't do that as often. And then you can use possibly like a CI/CD pipeline to do this trigger. I mean, there's all kinds of ways to do this. And then speaking about Terraform environments, I think that this is probably one of the biggest challenges that people have with Terraform. Like, how they've used Terraform to deploy one of their environments, like dev or prod or something like that. But how do you use it to manage multiple environments? And something that I've seen a lot, and I think I know why, it was popularized maybe before modules were really a thing. you would have a folder for every environment. So you copy all your configuration code, and you have like a dev folder, and you just copy it into that. And then you have a new deployment integration maybe, and you copy all your configuration code into there. And then I just don't like that approach, because what tends to happen is people skip steps, right? So they will change the configuration code in one of the deployments, but not the other ones. And so what happens is, over time, you have this evolution of the environments that are slowly diverging over time. And how do you get back to the same state? Now, what was in dev is no longer a representation of what is in prod. So what I would recommend is keeping all of your environments basically using the same configuration code. And what you do is you promote this configuration code from one environment to the next. And the only thing that really defines an environment is what version of the configuration code it's using, as well as what variables that are being set on the workspace. And please, just whatever you do, just do not copy the configuration code into different folders. If you need to do this promotion process, I mean, you could use GitHub branches or tagged releases. And in terms of like automation, you could do Terraform Cloud. So like Terraform Cloud, like you link the workspace to a specific branch or repository. You use GitHub Actions, some other kind of CI/CD tool where you're downloading the source, triggering the plan, doing the apply and approve, and then you might have like a separate exactly this pipeline, but for your prod deployment, where you are then using the same configuration code but with a different set of variables. And I think this is probably the best way, because it encourages you to use modules, which I think is one of the best abstraction tools, in especially versioning the modules, because each of your different environments can be using a different version of the module. And then it's very easy to upgrade to different versions as well. Another thing I didn't really mention was like blue-green deployments. So if you are, sometimes you can't always just do an in-place upgrade. You can't just change the configuration and then just hope for the best, because that can lead to some downtime between the plan and the apply. And I didn't include any slides on this one, but I just wanted to talk on this point, that I think that Terraform is maybe not well suited for blue-green deployments. What you can do is you can set up a new deployment, and then you can cut over to that new environment once you have your application running on it. So there's been some talks in the past about like using the create before destroy lifecycle hook. I wouldn't recommend doing that. I also wouldn't really recommend having like a blue and a green module declared in the same thing, and then using a variable to trigger between the two. So I definitely think that environments is the way to go. So that's all I had today, and I did have a coupon code to save 50% off my book, and I talk a lot about these different points. I also go into more detail about specific architectures and such. So I think it's a really great resource for anyone that wants to improve their knowledge or skills with Terraform. And yeah, thank you.
I'd like to ask you, Scott, where do you think Terraform will be in the next 5, maybe 10 years?
I think that Terraform is in a pretty good place right now. I think the language is very mature. We're already in Terraform 1. I think a lot of the breaking changes that we saw before Terraform 1 have mostly been resolved. I don't really think that there's going to be any major improvements to the technology, just iterative things, maybe around imports, maybe around testing modules. There's some experimental features right now with that. So I think we'll just see quality of life improvements, but I don't really see any drastic changes to the technology, and because it's just slowly maturing over time and seeing greater adoption as well.
Okay, thank you. I can see a question, so I put it on the screen. Can you see it?
Yeah, Terragrant. So I think that Terragrant served a good purpose at the time that it was created, but I don't think that it's necessary anymore because the technology has evolved kind of past that. And also Terragrant is kind of just supported by a relatively small company that just kind of does this as well as their consulting thing. I mean, they're only a dozen engineers or so. So I don't personally have any use for it, and I can't find myself to recommend it. But that doesn't mean that there's not people that are using it and are happy with it as well.